Hello everyone, welcome to this Port Skills and Safety talk. We are with Sally Friswell from ARUP, and we're going to be discussing electric vehicles and lithium-ion batteries and some of the challenges surrounding that. So welcome Sally, thank you very much for joining us. Can we start first by asking you a little bit about yourself and about the work that you do for ARUP?
Yeah, thanks, Jen. Thanks for inviting me to talk to you today. So my name's Sally Friswell. I'm an Associate Director at ARUP within the Fire Engineering team. So ARUP is a multidisciplinary global design firm working in all aspects of the built environment. As a fire engineer, we get involved in design of buildings, infrastructure, all sorts of places that people go. And a couple of years ago, we got involved in some research into electric vehicle fire safety, and we worked on behalf of the Office of Zero Emission Vehicles, which is part of the Department for Transport, and we produced a guide on their behalf with regards to electric vehicle fire safety in enclosed car parks.
Thank you. Yes, and we will circulate a link for that because it's a really interesting read, that with some really useful information and some great figures, which I think you'll probably refer to as we go through this, won't you?
Yeah, I will do.
So the first thing we wanted to talk about was about electric vehicle fires. There's quite a lot of discussion around the likelihood and severity of those fires, and I think it's really worth talking about that and maybe comparing how electric vehicles compare with internal combustion engine vehicles.
Yeah, absolutely. So when we started doing our research into electric vehicle fires, it was actually really interesting because we found it's surprisingly quite an emotive subject. It seems to have been the topic to do with electric vehicles that the people who are against EVs are using as this is why EVs are bad. And there's lots of news stories about, an EV caught fire in this car park, and kind of gives the perception that there are lots of EV fires. But actually, when you dig into the data, and that's the global data on EVs, that's not the picture that we're seeing. So the numbers vary, and we do need to bear in mind that EVs are a relatively new technology and they're a premium product, so they probably benefit from being well maintained and looked after and all those kind of things. So we might see the data change as time goes on. But at the minute, it looks like an electric vehicle fire is somewhere in the region of 10 to 20 times less likely to occur than a petrol vehicle fire when you look at it in terms of number of miles driven.
Okay, that's quite significant, isn't it?
It is really significant. We've then, and that's supported by insurance data, fire brigade data. So we've looked at it from multiple sources. And then when you look at kind of the actual fire severity and the fire behaviour, the peak fire size from an electric vehicle is about the same as the peak fire size from a petrol or diesel car. There's actually been some really interesting research done by one of the car manufacturers in South Korea who had a car model that they had as both an EV version and an internal combustion engine version. And they've done full-scale fire tests of the full EV, the full ICE vehicle, but then they've separately tested the battery pack from the EV on its own and the rest of the EV without the battery pack. So you get in a peak fire size in the order of around 10 megawatts, but about 8.5 of those megawatts are coming from the rest of the car, and the battery itself is only about 1.5 megawatts. So the internal fittings of your cars, all the foams and padding and everything else that's in a modern car, all the plastic trims and everything is actually contributing quite substantially to the fire, rather than the propulsion method being the big contributor to the actual overall fire size. The challenge with electric vehicles, though, is putting that fire out. It's a different type of chemical reaction once the fire gets in to the battery. And that is where the challenge is. You can't just spray a bit of water on and put it out. We know that you need actually huge volumes of water to put that fire out, and the battery is not easy to get to. There's the potential for the battery to reignite many hours after you think it's been extinguished because of that chemical reaction in the battery. And that's where the real challenge is in terms of electric vehicles.
I think that's really interesting and worth exploring a little bit more. That fact around the amount of kind of fire load coming from the actual car itself rather than the propulsion method is quite significant. It's something I wasn't aware of. You talked about the challenge around putting out the fire and those copious amounts of water that's required, and I think that's a challenge wherever that fire may be, on the highway or within a port environment. It's what you do with that runoff water, or how you contain and what you do with that runoff water, isn't it?
Yeah, so we've recently done a piece of research internally trying to answer that question of, is the firefighting water from an electric vehicle more contaminated than the firefighting water from any other type of vehicle fire? Again, it's still an emerging area of research. And what we've found is the water is contaminated. It's different contaminants to what you'd get off a petrol or a diesel fire, as you would expect. You do get those traces of heavy metals in that runoff water. But yeah, they're different contaminants rather than, oh, I'm not an environmental specialist, so I wouldn't like to say whether one is worse or better than the other, but actually both lots of water and contaminated. We should think about all firefighting runoff water and actually protect our water sources from those contamination rather than just kind of letting it discharge.
Yeah. And I think most ports and those types of facilities have some kind of system, as you say, to be collecting runoff water. And I guess it's a topic for us to explore in the future about how you deal with potentially those different types of contaminants within that water source. If ports are used to seeing kind of conventional fire runoff, then rather than that water that's dealt with an electric fire. You also talked about it being hard to get at the batteries.
Yeah.
That's because the batteries are generally in the underside of the vehicle, underneath the floor pan, aren't they?
Yeah, that's correct. So typically the batteries are in the underside of the car. They can come in different arrangements, but they're normally underneath. And it's not just that they're difficult to get at. The batteries are in a metal box because we need to protect them from the rain and road spray and all the kind of normal things that we don't want to get into the battery. So we put the batteries in a sealed metal box. The downside then being, if we get a fire inside that sealed metal box, you try and spray water at it if you manage to get underneath the car, and you're just spraying the water at the outside of the box. It's not getting right into where that reaction is taking place and being able to, you're not as efficient at the ability of cooling that reaction down and stopping it ultimately.
Cooling down was actually one of the things I was going to say. Yeah, by playing water on the external, you are just kind of cooling down that fire, the item that has the fire in it, but not necessarily dealing with the seat of the fire itself. Though we have another problem with electric vehicle or battery fires, don't we, to do with the kind of chemical reactions that are propagating the fire.
Yeah, so within the battery, it's a process called thermal runaway. It's a chemical reaction of once they've got too hot for whatever reason. So whether that's an electrical overcharge or short circuit issue, whether there's been some mechanical damage to the battery, whether it's exposed to an external source of heating, it can cause this thermal runaway process within the individual cells within the battery, and that is a chemical process that's self-perpetuating, and then it heats the cells that are next to it, and then they have that self-perpetuating process, and it keeps spreading until it's used up all of the combustibles within the battery itself.
And does that then feed into your other comment around the risk of reignition, because you have these separate battery cells that are then kind of one after another overheating and going into
Yeah.
thermal runaway over a period of time?
Yeah, so as you do the kind of firefighting activities, you spraying the water on, you can stop the visible combustion, so stop the flames, and you think you've got it out. But actually, if you haven't managed to cool all of the cells down enough below that key temperature where the thermal runaway can continue, that chemical process can be carrying on within the cells, maybe quite slowly. And then, 12 hours later, it's propagated itself far enough that you suddenly get the visible flaming again.
Yeah, that's really significant, because it's such a period of time that your fire brigade attendants have probably stepped away, and your emergency procedures are beginning to kind of slow down, aren't they? People are sort of reducing the level of awareness for a fire for that case. So it's really important then that we think about treating these electric vehicle and lithium-ion battery fires very differently when we look at our emergency response.
Yeah, absolutely. Even when we're working with our car park clients in a much more conventional car park arrangement, we are now spending quite a lot of time saying to them, okay, these are your prevention methods. We get to the point the fire brigade come in, the fire brigade go. Now what are you going to do? You don't want to leave that burnt out car in your car park. You need to have some kind of plan for it to be removed to somewhere where actually it can sit, and if it does reignite, there's no risk to anybody, there's no risk to other buildings, and it's quite a challenge of especially multi-story car parks. How do you get the car out?
Yes, yeah, and there are we have seen that manufacturers are beginning to respond to some of these challenges with technology and equipment that might be able to assist in some of these firefighting, or the sort of response and recovery afterwards. But it's got to catch up, I guess, hasn't it, with the technology itself and the challenges that we face.
Yeah, with any new technology or new fire hazard, it kind of does take time for the codes to catch up and for the firefighting response to catch up and kind of work out what's the best way of doing that. Obviously, there are some novel ideas that are out there in the market of how you might put out a fire in an electric vehicle. There's quite a few companies out there who are using the idea of a fire blanket that you can then pull over an EV, and it's going to put the fire out for you. And there's some demonstration videos. I'm sure you can find them online. But you've got one car in a large space. The people pulling the blanket are several meters away from the car. A lot of the videos I've seen, the fires actually in the passenger compartment, not in the battery. So it kind of go, well, actually, does it actually work? And also, how realistic is it that you could deploy such a system on a car that's on fire? Like, even in a conventional car park, you haven't got much space between the cars. Then when we start looking at how you have them in a port, when you're in an import-export scenario, you've got even less space. So there's just like, it's impossible to even think about deploying a system like that. The systems I've seen that I think, oh, actually that could work, are a lot more water-based ones. The Municipal Council in Amsterdam have adopted an approach of, they've basically got shipping containers on the back of wagons with cranes, and the shipping containers filled with water, and their plan is, if they get any EVs on fire in the city, to pick them up with the built-in crane and plop them in the shipping container full of water and leave them there for 48 hours. And you deal with a fire, you've then got a shipping container filled with contaminated water. So solve one problem, create another. I've also seen like mobile deployable bunds. So once you've got a fire, you then come and erect this mobile bund with metal panels around your car on fire, and then you fill that bund full of water and use that in situ. Again, they're kind of promoted on the basis of just going around one car, and I don't think it's very practical. That you'd go that close to a car that's on fire. But actually, if you could get bigger ones that you might go, okay, we'll go around 8 cars or 6 cars to keep people at a safe distance away from the fire, that might be a solution that could be taken forward as a real effective way of dealing with that fire, acknowledging you're probably going to lose half a dozen or however many vehicles as a result of it.
And I think that's the trade-off, isn't it? Is the loss of asset against protecting or improving the safety of anyone, the firefighting response team, whether they be the actual fire brigade or a response team within the port, or in fact, on a vessel as well. I think those are really interesting kind of options, and I think I've not heard a great deal about the bund option, but it does seem this thing about using large amounts of water, which we know work if you can get them out the battery. That is an option to be considered, isn't it? And as you say, with shipping containers, as long as you can physically pick up the vehicle to put it into the shipping container in the first place, then yes, you've got rid of that one problem, and you just left them with contained contaminated water. So it gives you a bit of a chance to deal with it rather than it be running off kind of paved areas, I guess. The fire blankets, now that's one that we've heard quite a lot about, particularly in the port and the shipping sector. And I understand they're quite large and can be quite heavy to deal with. And I know that some ports have been exploring with their local fire brigades whether these are potentially options. So it's really interesting when you say that some of the demonstrations that we see on YouTube, and I think most people will have seen a video on YouTube showing that, it's really interesting that it appears that the fire hasn't been set in the battery unit itself, that fire has been set just as a demonstration, because as you say, you've got different types of fire, haven't you? It's then just burning the foam and the plastics and from the interior and the structure of the car rather than the actual propulsion system itself.
And you'd fully expect a fire blanket to work on a conventional fire. That's why they're put in kitchens. We know you can smother most fires. With the batteries, because it's a chemical reaction, because it can generate its own oxygen, covering it with a blanket isn't necessarily going to do anything.
Yes, because you're no longer removing the oxygen, because that battery is going to generate its own oxygen to keep the fire going. Is it possible to use those fire blankets as a protection for sort of surrounding vehicles? So could we use them to surround other vehicles that are potentially not on fire, but we want to protect them from heat and the damage that could be sustained?
I don't know. To be completely truthful, I don't think so would be where my thought process would go in it. The blankets aren't that effective at stopping heat coming out. So if you've still got a chemical reaction going on within a battery that's releasing heat, is a blanket going to stop sufficient heat to get into the adjacent battery? Particularly how close you put them together on ships and in ports. So I think probably not, but it's probably a question that actually could be investigated. But I'd want to see some data before I kind of endorsed that as a potential solution. And you've still got the challenge of how do you deploy those blankets even over the adjacent vehicles. You're not, like, a vehicle fire is not something that we should be encouraging people to go towards unless they really have to, unless they're trained to tackle the fire and can do something effectively. I wouldn't want to put someone at risk to pull a blanket to protect a car.
It's a really good point. Thank you for that. Yeah. And I think it is interesting, though, that they are designed, as you say, primarily to smother and remove the oxygen rather than to protect, rather to contain heat. We've kind of covered the vehicle fires. I think one of the increasing things that we see in ports and potentially partially in shipping as well is around charging facilities. So we've not just got third-party vehicles coming in and out of ports and on and off vessels, but increasingly ports are using their own electric vehicles, so they have electric plants. So we have lots of different plants that is now electrically electric vehicle rather than being rather than being kind of diesel powered or an internal combustion engine. So what considerations should ports have when they're looking at charging facilities and how they might deploy those, where they might position? What kind of things do they need to think about, Sally?
So in terms of charging, it's worth noting that there's not a really clear picture that charging is much more hazardous than not charging. I think that partly because of how fire data is gathered, but from a first principles point of view, charging induces a current which generates heat. So you kind of think actually it is slightly more likely that you're going to get a fire in those scenarios. And it's about making sensible provisions in terms of locating those charging points. So some of it's around actually how you arrange the chargers and the parking bays associated with them.
Yeah.
So you want to make sure that you've got simple things like vehicle barriers so that somebody can't drive into your charger and damage it. You want to think about that if I've got a charger at the end of a parking bay, is the cable connection point to the vehicle on the right side that I can easily connect into it. Like my former workplace, we had to reverse park into parking bays. So if your charging point was on the front of the car, you'd have to trail your cable from the back of the parking bay to the front of your car. A cable trailed on the floor means somebody could drive over the cable, which could then induce damage into the cable. So they're actually very sensible kind of provisions. If you've got high fire risk activities going on in the port, maybe you've got like a maintenance workshop that you do some welding. Well, it's common sense that you then don't really want to put your charging right next to your highest fire risk. Like there's no hard and fast rules. It's about just quite sensible, common sense steps of where you're locating them away from hazard areas. And ironically, actually, if you drive around the country now, you see a lot of charging points on petrol stations. And I'm like, I can't square that in my head as a sensible way of doing it. But that's what's getting approved. It's meeting all the standards. So you kind of could probably put them anywhere anymore.
I think it's a very good point. Two very good points that you make. The actual physical arrangement of how you're going to charge that vehicle, how you're going to access both the charging plug on the charger itself, but then also on the vehicle. How is that arrangement going to be so that you can have bays of vehicles charging? But then not only, I think it's a great example with the maintenance facility that might be welding, but we also on ports store other cargoes that are at risk should there be a fire close by. So that's another consideration, isn't it? So I think it's all about really understanding the risks before and putting all of those into planning when these points are being considered.
Yeah, you might also want to think about things like some places are now wanting to use solar power to charge their chargers. So they're kind of put in like canopies over the top of their charging bays, and then solar power's on top of the canopies, which adds an extra level of complexity onto your system. So then you need to think about, actually, if I do have a fire, how do I isolate the solar chargers so that I'm not adding more charge into the fire?
To a fire.
Yeah.
Great, thank you. I think the other thing we wanted to cover was about vehicle storage. So you said that you have done some work around car parks.
Yeah.
Covered car parks, and although not all storage facilities within ports are covered, there can be incredibly large car compounds with cars parked very close together, and on vessels, vehicles are generally can be undercover and again are parked very close together. So I'd be interested if you could tell us a bit more about what your research has shown and what advice is given around those circumstances.
Yeah, so unfortunately, you can't do one of the things that we would always advise is increase the spacing between the vehicles. So when we look at like other options that we've got, so when you're on ships, you've generally got your sprinkler systems and some smoke control already on there, and actually they're the two best systems that you can put in, short of kind of spreading the vehicles out. We need to acknowledge that if you have a fire in an EV, or to be fair, in any vehicle, and your sprinkler system activates, it's unlikely to put the fire out in that vehicle, but the sprinkler system will cool everything else around that vehicle and kind of contain the fire to the one vehicle. When we start looking at the port side of things, and you're not in a covered environment, obviously it's much more difficult to take measures. And there's probably a challenge for you of kind of how many vehicles are you willing to lose if you had an EV fire in your car park, thinking about actually whatever our number is, we need to have a break of a couple of meters, and then we have the next number of vehicles to try and limit that spread until such times that either the firefighting approach is refined and more reliable, or the battery technology or car design moves on such that this hazard that we're talking about today has been designed out and isn't a hazard that we need to think about in the future.
And that probably leads us on to talking about kind of car design. And is there are those risks and those hazards being addressed by manufacturers? Are there things that are being done to reduce that risk?
Yeah, so I've heard of car manufacturers looking at things like whether they can almost have like fusible links connecting the battery to the underside of the chassis. So as they warm up, the battery essentially drops on the floor, which makes it then easier for firefighting. I haven't actually seen it come into production on any cars yet, but I know that's things that's been researching. I actually think the long-term answer is going to come from the battery market rather than the car market. There's huge amounts of research being done in terms of battery technology at the minute, and they're looking at things like solid state electrolytes, moving away from the lithium and using other metals in the batteries, which just massively reduces the fire hazard. Lots of people recognize the amount of lithium in the world is very limited, so we can't continue on this path of relying on lithium-ion batteries. I suspect if we have this conversation in a decade's time, it'll be a completely different battery technology, or it might even be a completely different way of transportation, I don't know. But I don't think the hazards that we're seeing today and discussing today are going to be the same hazards in 10 years. Time, because that technology is changing and moving on.
That's really interesting, and I think that's probably a good point to end on, that look forward as to where we're going to be in a decade's time. So I'd like to thank you very much, Sally, for your expertise and your time today. It's been a really interesting conversation, and can we book you for a decade's time to talk again?
Yeah, absolutely.
Thank you very much.
Thank you, Jen.